much more difficult to balance because the oxidation number changes in the redox processes are not nice numbers like 2s and 1s. So on these ones, for me personally, the best way to do these is via looking at oxidation number changes. Now, this requires you to be quite good at oxidation number work. So that's one of the skills you will need to sort out before you get going on this one. But I can tell by looking at this that the oxygens and the hydrogens haven't changed oxidation state, neither have the sodiums. That's because these have fairly fixed oxidation states when they're in a compound. Oxygens -2, hydrogens +1, sodium is +1. Their only other normal oxidation state is when they are an element. So because none of these have changed from being in a compound to being an element, we're saying almost immediately that none of those oxidation numbers have changed. Therefore, that just leaves us with the fact that the chlorine must have changed oxidation state. It's gone from 0 here to +5 here. And it has gone from 0 here to -1 here. That means that we had 1 electron involved in this process and we had 5 electrons involved in this process. For these to balance, the electrons going both either way have to cancel out. That means that for this equation to balance, we need to times this whole bit by 5 here. So we need to put a big 5 in there to start with, to say that for every one of those that was made, 5 of those had to have been made so that our oxidation state changes cancel. Having done that, everything else falls into place after it, because that gives us 6 sodiums, which means we need a 6 in front of there. That means I need 6 oxygens. I've got 3 there, so I need 3 there. So my sodiums are okay now, my oxygens are okay now. I need 6 hydrogens, I've got 6 hydrogens, my hydrogens are okay. The only thing I've not double checked is chlorine, and I've got 5 there and 1 there, so I need 6, so I need a big 3 in front of there overall. So we fairly quickly, provided we can see what's going on with oxidation numbers, we can get to a balanced equation with that one. The one below is similar. In the one below, again, we've got no hydrogen as a gas anywhere, we've got no oxygen as a gas anywhere. Therefore, my hydrogens and oxygens are not changing oxidation state. However, we need to check what's going on with antimony, and antimony is going from 0 here to +5 here. Nitrogen, on the other hand, is going from +5 here to +4 here. So this one is gaining an electron, and this one is losing 5 electrons. So once again, if these two processes are going to happen and the electrons can cancel out in the processes, we're going to need a big times 5 on this top one here. So that means I'm going to need 5 of those and 5 of those to make this balance. If I go back to my antimony, I need 2 of these. So if I need 2 of these, I've just changed this to a 10 electron process. So that means that I also need to put a 10 in there and a 10 in there. And then we take a check of where we are at. This gives us 30 oxygens this side, and on this side I have got 5 here, I've got 10 there, but I've still not got the right number here. That's because I need 10 hydrogens, so I need 5 waters there to make 10 hydrogens. So taking another review back through this, yeah, my antimonies are okay. My hydrogens are now okay. I've got 10 on both sides. My nitrogens are okay. I've got 10 on both sides. And my oxygens have got 30 on this side. And on this side, I've got 20 plus 5 plus 5. I've got 30. So I'm now balanced. So just writing that out again, I should have this as my final equation.